Welcome guys to my YouTube channel. In today's class, I'm going to be teaching you resistors in series and in parallel, part 2. Okay, that is to say, don't forget that this is a subtopic. This is a subtopic of current electricity, what we call simple DC circuits. Now, if today is your first time of coming across my YouTube channel, please do well to subscribe to this channel and also on your notification bell so that whenever we post video, you will be notified. It will get across to you. Now, in today's class, I'm going to be teaching you strictly calculations on resistors in series and in what? Parallel. Don't forget, in our previous video, I showed you the formula used to do calculations involving resistors in series and resistors in parallel. I think it will be important for us to just go through it a little. Take a look at this class. Now, if I have resistors like this, which is R1, I have another one which is R2, and I have one here which is R3. Now, this resistor on the board are connected in series. The reason is because if the current enters this resistor, that same current that leaves here will get to this place, and that same current will get to this place. So in such a connection where there's no division of currents, where the current moves in a particular direction, is what we refer to as series connection. So if you are to calculate for the net resistance, or what we call total resistance, it should be calculated by using a very simple formula, which is R1 plus R2 plus R3. Yes, this is the connection in what? In series. So it's quite very cheap. Now, if you have connections in parallel, how will you solve it? Very easy. First of all, let me show you what a parallel connection is. A parallel connection is a connection that looks like this. Take a look at the diagram on the board. This is R1, this is R2, and this is R3. So if I have my R1, R2, R3, and they are all connected to the same particular source, let's assume the current is coming from here. Now, if the current comes from here, you discover that the current at this junction will split. So in a parallel connection, there is a junction. A junction is a point where three or more circuit elements meet. So, you know, the flow of current is like the flow of water. If water comes this way and you have three lanes, you discover that some of the water will flow here, some will come here, and some will come here. So because there is a division of current, that's why we say that this circuit is connected in parallel. So the total resistance is given as 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3. I showed you how these formulas are derived in our previous videos, okay? So you can go back to search the video, or I will drop the link in the comment section of this particular video so that you see how this formula and these formulas are what are derived. Now, take a look at the diagram again. If we have just two resistors that are connected in parallel, instead of passing through this long step, you can use a very short cut. Okay, for two resistors only in parallel, we can have R total is R1 times R2 over R1 plus R2. Yes, so the formula showed us that we have product over weighting over sum. The product means to multiply them divided by the sum of the two resistors. So this one now is only applicable if I have two resistors only that are connected together in what? In parallel. Now let's dive into the question for today. Take a look at this question. What is the resultant resistance of the circuit given? This circuit is from your JAM exam. Now, if you have a question like this, how will you solve it? Very easy. Look at the board. This is the first resistor. You have 3 ohms, 4 ohms, 2 ohms, and what? 2 ohms. Now let's assume there is an applied voltage in this connection, like we connect battery to this guy. Let's connect it this way. You see that let's assume we have something like this, and this is the voltage. Now if I connect voltage here and the current is flowing, watch carefully. The current passes through this particular resistor. When it gets to this place now, What did I tell you will happen? The current will split. And when it splits, you know that these two guys are in what? Parallel. So it is quite very easy. That means if the current gets here, it will divide like the way water will split. So these two resistors will be here now. They are connected in what? In parallel. So if they are in parallel and they are two only, I showed you a shortcut to use. Product over sum only for two. Don't get me wrong. So in this place now, I can simply tell you, watch this carefully. Don't worry, you understand it. Watch it carefully. Arrow 2, which is this one, is parallel to the other arrow 2. Yes. So because of that, we have product over sum. Products divided by their sum. So product means 2 times 2, sum means 2 plus 2, and that will give us 4 over 4, so that we have 1 ohms. So it means that the combination of only these two will give us 1. Don't forget we are looking for the total resistance in the circuit. Now, if this gives us 1, our circuit diagram is going to be like this. Watch carefully. We have a resistor here now. These two guys have been combined together to give us one single resistor. See? Then this one now is one resistor on its own. So the applied voltage still remains at the same position. Watch carefully, please. This is 3 ohms, okay? This one is 4 ohms, okay? Then we have combined these two together as a single resistor. So we have 1 ohm here. See? Then what now becomes the total resistance? The total resistance, arrow total, because this connection is now in series, as you can see, end to end. See it, the current will flow without dividing. We now have 3 plus weighting 1 plus weighting 4, and that will give us weighting 8 ohms. That is the answer to this particular question. Now let's take question number 2. Now let's take this second question. The total resistance of the circuit given below is what? I've told you, analyze the flow of current. The flow of current will indicate whether it is parallel or series. And when the current flows there and it gets to this place, what do you think will happen? Can you guess? The current will divide between this one and this one. But look at this carefully. This current now that enters these two is the same current that enters here, because it flows through this wire and gets to this place. Therefore, hold on. Between this guy now, this guy that is here, this one and this one, between two of them here, because there's a division of current between two of these guys, is called parallel. Why? Because it divides here. So yes, and here they are parallel to each other. So what do we do? Very easy. But these two guys now, this one, these 2 ohms and these 2 ohms, they are connected in series, because the current that comes here is what comes here. So for this one, we can say arrow 2 is in series with the other arrow 2. And what would that give us? We simply add it together. Yes. So that we have 2 plus 2 to give us weighting 4 ohms. That's for these two in series. What about these two? The same thing. Arrow 2 is in series with arrow 2. So we'll do 2 plus 2 to give us 4 ohms. Are we together? Now, at this point now, you discover something, that the circuit is going to be like this. Watch carefully. This is the first resistor, which is 1 ohms, connected. At this point now, you have 1 here, which is this one, which is 4 ohms. You know, we have combined these two, we got 4. There's another one here. There's another one here, which is, we have combined these two now, we have another 4 ohms. So we have, they are connected together this way. Then we have 1 here, which is 1 ohms, and we have our applied voltage thereabout. Did you see it now? We combine this in series to get 4. We combine this to get another 4. So this is the 4 and the 4. This is now how the circuit diagrams looks like. So how do you solve this? Remember, say, this guy now and this guy, they are what? They are parallel to each other. And because they are parallel, to combine them, you will use that shortcut I gave you, product over sum. So that means that arrow 4 is parallel to the other arrow 4, which is these two now. Combine them by using that formula, which is product over sum. Product over their sum. So their product is 4 times 4, and their sum is 4 plus 4. That will give us 16 over 8. And what you have there is what? 2 ohms. Wow. So if I combine these two, they will not be one single what? Resistor. Do you understand? Yes. Now, these two gives us this. The circuit diagram will look like this thereafter. Our circuit diagram will look like this. We have 1 ohm resistor here. These two has been combined together to give us 2. So you have 2 ohm resistor. Then you have 1 ohm resistor here, 1 ohms. Look at what we have. This is our applied voltage. This is our applied voltage. So if you analyze the flow of current now, you discover something, that the current that enters here is what enters here. The one that enters is what enters here. Look at it. There's no division of current. So the final total resistance, R total, will be equals to 1 plus this 2 plus this 1, because they are not in series. So that will give us waiting 4 ohms. Now, let's take more questions so that you understand it better. Let's take some difficult questions. Now, let's take question number 3. According to this question, you have a resistor connected together like this. Calculate the total resistance. In both cases, this. Calculate the total resistance here. In both cases, how will you solve this? Very easy. For this, if you analyze the current, let's assume the current begins from here. Okay, it flows like this, come like this, flow like this, and flow into this too. So it means that this connection is in what? Series. So because of that, we'll simply just do R total is equals to, we can number it 1, 2, 3, 4, 1, 2, 3, 4, 5, and 6. That means we can say 6 times 4, or you simply do 1, 2, 3, 4, 5, 6. And that will give us 24 waiting ohms. The circuit is in what? Series. Now what about this? Watch this carefully. This one, if the current comes from here and get to this place, there will be a division. And if you observe this and this, they are connected side by side. I told you before that when a resistor is connected end to end, is in series, but side by side is parallel. That means these two are in what? In parallel. Make sure you always combine the parallel first, so that it will be easy for you to solve the series. So for this, we have R10 is parallel to the other R10, for which we'll do product over what? Over sum. So product is 10 times 10. The sum is 10 plus 10. So we have 100 over 20. And that will give us 5 ohms. So the circuit diagram will be like this. Good. So you have 10 ohms, you have 5 ohms, and you have 10 ohms. You know we have combined these two together to give us 5. That's why we have 5 here. So our total will be 10 plus 5 plus 10 to give us what? 25 ohms. Okay? Now let's take 2 more questions before we call it today. Now let's take the last question for today. Now this is your question number 5. Please don't forget to solve this question by the time you are done with today's class. Solve this question and send your answers in the comment section. I'll mark it there. Okay, before that, let's solve this question. Take a look at this circuit diagram. The current passes from X to Y and returns like that again. Now, if the current gets to this place, what you discover is simple, that some current will come over here, some will go here, some will come here. So the 3 of them are parallel to each other because there's a division of current between them. So in that case, this is what we simply do. Our formula for parallel connection is 1 over arrow total equals to 1 over arrow 1 plus 1 over arrow 2 plus 1 over arrow 3. Don't forget that we can only use product over sum for 2 resistors in parallel. So what do? 1 over arrow total equals to 1 over, the first one there is 20. Okay, plus 1 over what? The second one, 5, plus 1 over what? 4. So what do we do now? We'll do 1 over R total equals to the LCM of 20, 5, and 4 will give us 20. So 20 divided by 20 is what? 1 times 1 is what? 1. 20 divided by 5 is what? 4 times 1 is 4. 20 divided by 4 will give us what? 5 times 1 will give us waiting 5. So 1 over R total is equals to, this will give us 10 over 20. So what do we simply do? Cross multiply. We now have this times this, that's 10 RT equals to 20 times 1, 20. Then we divide both sides by what? 10. This cancel this. R total is equals to 2 ohms. So this is the answer to this question. Don't forget to answer your question and send it to me in the comment section. I will see you in the part 3 of this video lesson, where we'll be solving for current and voltage across particular resistors. Thank you very much. I'll see you in my next video.